All right, so we're going to be looking at shell method. This is another method to finding volumes of shapes being rotated around some axes. So whether it's the x-axis, the y-axis, or some other horizontal or vertical line. So we've looked at washer method. So if we were rotating around the y-axis, we had a line that was perpendicular to that, and then we would rotate it around. We looked at cross sections where we had different shapes and we had to find the areas of the shapes and then multiply. Well, not multiply, we'd take the integral of it because it would change depending on what the x or the y value was. This time this is very similar to washer method, but slightly different. So what I want to look at is given some function, let's call this, that was bad. Let's call it x squared. So if I took a line right here, so we know if I go from the x-axis to the function, that's just the function height. I'm going to take that and I'm going to rotate it around the y-axis. So we are perpendicular. So I'm taking, here's the y-axis, and I'm rotating this line around the axis here. So let's think about a shape that would be created if I were to rotate this around. So we're looking at something like this. Sorry for the bad drawing. So we are creating a cylinder. So I took a height and I go and I wrap it around. We're going to create a hollow cylinder. So a hollow cylinder. So depending on what the height is, or where we're at on the x value is going to determine the size of this. So what we want to do is we want to take an infinite number of these. We want to wrap around infinite heights around the y-axis, and then we're going to sum them all up. We know that to be integration. But think about if I took this cylinder, this hollow cylinder, and I kind of sliced the one side and then unraveled it, we would have just a rectangle. So how do we find area of a rectangle? Well, base times height, right? So let's think about the base. If we were to take that cylinder and unwrap it, what's the base going to be? It's going to be this circular piece, which we know is just circumference of a circle. So circumference of a circle we know is given by 2 pi r. Okay. And then this outside piece is the height. And then I want volume, so think volume. So this is infinitely thin, but if we think about this infinitely thin side to this rectangle, we have the change in our x value. Like I said, we're going to take a cylinder and then a slightly bigger cylinder and a slightly bigger one, and we're just going to add all the volumes together to get the big shape that's created. So the height is just the function. So in this case, it's going to be f of x, and then 2 pi r. So think about what the radius is. So from the y-axis out to the edge here, out to that function height, that's going to be an x value. So we can say 2 pi, our radius, like I said, is the x. That's the distance from the y-axis because that's where we're rotating around. And then we have times a height, which we said that this is a function, f of x. That's the function height. And then volume, length times width times height. So we need a width here, which is our dx. Okay. So now if I take a bunch of these and add them together, we're going to get the overall volume of the shape. So we know that's integration. So here are the formulas. volume of a cylinder over and over and over again. We're adding it. So we have an integral between some x values. So I am using this when I am rotating around the y-axis. So it's different than washer method. Washer method, we rotate around the y, we had to be in terms of y. But if we're rotating around the y-axis, we need to be in terms of x. So it's the opposite of washer method. So this is rotating. So rotate around the y-axis, and then if we are rotating around the x-axis, we have to be in terms of y. So remember, if I'm rotating around the x-axis, I have some distance like this. Remember, my two lines are parallel, and we're going to be rotating this thing around the x-axis. That's why we have to be in terms of y. So it'll take a little getting used to when we're thinking about shell method. So let's get into the first example. So find the volume of the shape created when you revolve the region formed by the following functions around the y-axis. So we are going around the y-axis, so we need to be thinking we're in terms of x. So the function is given by x squared plus 1. So we're already in terms of x, so we're all good. X is 0, so that's the y-axis, so that's right here. Y is 0, that's the, sorry, x is 0 is the y-axis. I pointed to the y, I said x. And then y is 0 is going to be our x-axis, this bottom piece. And then x is 2. We know that is a vertical line right here. So we're looking at this shaded area here. And we're going to take that whole shaded area and rotate that around the y-axis. So I have a little piece here, kind of like what we had before. And then I have our radius and then a height. So I took that height and we rotated it around, and this is what is being created. So overall, we're going to have kind of a bowl shape. We've dealt with this before with washers, just looking at it with this method. So now we need to build our integral. So remember, integral is given by 2 pi. So I'm going to go ahead and take this on the outside. 2 pi times our radius. So our radius in this case is the distance from the y-axis, so the x value, times the function height. So our function was x squared plus 1, and then our width is dx. Okay, so there's our function. Now we can go ahead and figure out what the boundaries are. So we are going in terms of x. So x is 0 to x is 2. So 0 to 2. So we can clean this up a little bit. So x cubed plus x. And then we have from 0 to 2. And then 2 pi on the outside. And we go ahead and integrate this. So integral antiderivative of x to the third. That's going to be x to the fourth over 4. Antiderivative of x is x squared over 2. And we're evaluating that from 0 to 2. And we're just going to go ahead and multiply that by 2 pi at the end. So if we plug in the 0, that's going to cancel both those terms out, so we don't have to worry about subtracting that. So if we plug 2 in, 2 to the 4th power is 16 divided by 4 is 4. 2 squared is 4 divided by 2 is 2. So we get 4 plus 2 times 2 pi. So 6 times 2 pi would be 12 pi. So the volume of that shape created by rotating around the y-axis is 12 pi. So that's it for this video. I will make other videos on some more difficult problems.